Cool. So, how's it going, everybody? My name's Cole. I'm a senior here at the University of Georgia studying computer science. I primarily am into web application exploitation, hence teaching this first course or this first seminar. Earlier this year in the spring, I competed in NCL, and in the individual game, I placed eighth in the country. About 7,000-ish people were in that competition. So that one came down to just speed. Everybody that was within the top, however many hundred, like several hundred, were like perfect scores, but I was the eighth quickest to get to that. So web is kind of my forte. I'm very into that. I do a lot of web development, and then that has led over the years to having an interest in web exploitation. So the primary tool that we're going to be using for this is Burp Suite. I sent out a message earlier. If you want to follow along, I recommend you download that. It's very easy to install. But if you haven't yet, you can still follow along. Just take notes, or the slideshow will be available for y'all later. Yeah, it is also free. It's a free application. It's really useful. So, do any of y'all have Burp Suite installed? Perfect. Very, very good. Very good. Good, Ethan. We can move on though. Y'all can just follow along. It's all good. Um, so, web application exploitation. It is the process, of course, of finding and exploiting vulnerabilities within web applications so that you can gain access to sensitive data and sometimes control over that application. So we'll go through a few of the more typical attack vectors that you'll see in our competitions. The first three, SQL injection, command injection, and path/directory traversal, we will have examples to work through, so y'all can follow along with that. It'll be pretty cool. And then the last two, cross-site scripting and cross-site request forgery, those are a little bit more nuanced. It's not so one-dimensional as the other three, so we won't do that today, but I will go over it slightly today. Note, this is not an exhaustive list. There's a lot more to web app exploitation, but in the context of the competitions we typically compete in, these are the main styles and categories that you're going to be seeing. And this is just going to be a very basic introduction to them. Your problem solving skills will carry you into the more complex solutions, just knowing the basics. So for the first one, we have SQL injection. So a lot of you probably are familiar with the query language SQL. A lot of times when you have database leaks and things like that, it is due to a SQL injection attack. And what this typically looks like is just statements that are not either like prepared queries or parameterized queries, or just don't have any type of sanitization and just allow user input to be straight away put into the query. So in this example, we have string query equals select all from items where ID is input. It's a terrible query, awful, and you can exploit it very, very easily, as you can see in this bottom area. So the expected input here is something like ID is 1, 2, 3, 4, something like that. But when you are writing applications in any terms, you have to expect the user is malicious, always. One, users are typically not going to follow your practice, and two, they could actually be trying to get all this sensitive data. So knowing that, avoid doing things like this, but in our case, we love when websites do things like this. It gives us a very easy attack vector. So doing something like close parenthesis or 1 = 1 dash dash. Let me break this down a little bit. So in our query here, we see that the website or the web service opens up the parenthesis and then puts your input here and then closes it. Expected is just like some numbers or something that it would have a proper syntax like statement. But if you close that parenthesis, add an or, which is this is true or the next thing's true, and 1 = 1, which is always true, that is going to give you a valid statement. And so then it's just going to return everything within the items table. Those dashes are a comment in SQL, so it closes that statement right there. So nothing after that, like this malformed extra couple of parentheses, none of that will be executed. So that's a really simple example, but it kind of gives you a little bit of an idea of what this might look like. Do you all have any questions? If you don't completely understand that, it's completely fine. You know what I mean? This is one of those categories. There's plenty to choose from, but this is a simple introduction, and I'm happy to go into a little bit more depth at any time. So we're going to go through a work example of this. Wow, I don't have it here. Can Give me 1 second. Sorry, y'all. I think so. Yeah, we were like going cross between two different slideshows, so I think excellent. Yeah, here we go. So here's our SQL injection example. We're going to use Pico CTF, the gem, which is something that I mentioned for y'all to use last week. Pico CTF is Carnegie Mellon's Capture the Flag competition. Their gem is full of really, really good introductory challenges, all the way from introductory to hard or advanced level. And online, there are plenty of walkthroughs to understand and to work through with those. And that's how I learned a lot of these categories. Go ahead.
To add on to that, these are actually all the challenges here are challenges that were in previous actual competitions.
Yeah.
So they're very good simulation for the actual competition.
So this challenge we have is called Web Gauntlet. It's stated as a medium challenge. Oh, well, there we go. My bad. And then we're given 5 hints. Hints are going to be a typical thing you're going to see in challenges. They're not necessarily, oh, this is the solution. It's more of just like, let me get your mind in the right frame so that you can approach the challenge correctly. So always look at the hints. Don't, like you don't need to approach a challenge like, I'm going to try to figure it out and then look at the hints. Just look at the hints. They're there for a reason. So in this challenge, we have you're not allowed to log in with valid credentials. Write down the injections in case you lose your progress. There's filters. And then it says SQLite. So that's going to be useful later in the challenge. That's just one type of SQL database manager, SQLite. And these different database managers have like different syntax. That's worth noting. So we can open this up. I think it should be, round 1. So we're shown a username and password prompt, a login prompt, and we're shown that we have 5 rounds. So we also have this URL that is filter.php. Typically with injection challenges, there's going to be some filter that will prevent you from doing something a little bit easier. So in this case, or is filtered out. That example I showed y'all before, we used or. So we're not going to be able to do that in this example. But we can figure out something else. So let me just test how this will look for us. I'm just going to put in user and pass. So given that this challenge is relatively beginner level, it shows us what the outcome of our inputs is. That's going to be really useful in tuning down a successful injection. So for this first one, and for almost any challenge that is SQL injection, you're going to want to get into an admin account. So I'm going to set that username as admin. And as you see here, I think y'all can see, as you can see up here, we have the username first. So if we can figure out a way to break out of the rest of this using like a comment, like I mentioned before, that is going to be very useful because all we need to specify is the username. So if I put admin and then close out of that quotation and then add the comment note, that will stop the comment, or that'll stop the query right there. So then it doesn't matter what I put for password. I can put 123. And so this is what that looks like. Select all from users where username is admin. And then right here, this signifies nothing else in the rest of the statement is going to be read or processed. Does that make a bit of sense? Cool. So now we can go on to round 2, and the filter has changed. What did you say? Yeah, admin is just what's typical, but I mean, over time you'll kind of get what you're looking for.
What did you enter again?
It was admin quotation dash dash.
You're
Yes.
basically closing the string up and putting a comment at the end, which tells the SQL query to ignore everything after the username thing.
Yeah.
And the 2 dashes are what indicates that's a comment. Everything after is a comment. So the and hazard just does not matter.
Exactly.
And where'd you get the like the select dash from? Like where'd you get like the text that's on?
The website gives that to us.
Yeah.
So it's this is like a kind of one of those like trainer things. So the website kind of shows you what's going on in the background that you're not seeing.
Why can't I see it?
Let me come look real quick. Sorry. There's no password. And then there you go. So it requires that you have like some kind of password. That's just a HTML form
Okay.
thing. So round 2, we can look at the filter. It's been updated. Now we can't use and, like, equal sign, or the comment that I used previously. So we still need to get in as an admin. So I'm going to go back to that. And we can't use the dashes for a comment. There are plenty of other ways to make comments. The main other one, I believe, is just a slash and a star. As you've seen in some languages, slash star star slash is like a full comment, and whatever goes between those asterisks is that comment. So we're going to try that. It's going through the exact same logic as our previous one, except instead of the dashes, we're using the slash and the asterisk. So that worked, and this is what it shows. Again, this is all that is actually being interpreted because of that comment. So everything out here behind this is getting, I guess, just escaped. Like, I don't know the better terminology for that, but that is your goal with challenges like this, where the username comes first. Go ahead.
Let's say you did this slash star in the first round. Would it then filter out the slash star, or does it have to be like in order?
You do it in whatever order. As long as you are respecting the filter, it's not like one of those where it will use that. We could have done that for both. I'm just trying to show a little bit of like variance. So then we're now on to round 3. We can check the filter. I think the difference is these alligator brackets and then equals. Maybe the equals is there. We can do the same thing for round 3. They didn't filter out the comment, so we're going to do that. Actually, it should work. Yeah, it should work. I'm going to do something else, though. This is a way to end a statement, and that's pretty typical in most languages. I think that'll work. We're still specifying user as admin, and using our semicolon, we're breaking the statement right there. So yeah, that worked, and you see this is out of there because the semicolon, pretty straightforward. This fourth one, we can't say admin, which, yeah, that's pretty straightforward. Does anybody know SQL like extensively, or SQLite specifically? Perfect. I can share something though. In SQLite, if you use I'll just show you. I don't know what it's called. 2 of this sign, that is concatenation. So if you have 2 strings, 2 lines between them, that will concatenate into one string when the statement is processed. So we can't use admin in our explicit input, but what we can do it connects those strings. It concatenates them, and now effectively we are doing the exact same thing as before. We're still saying admin, but we're doing it a little bit differently to the point where we're expecting this filter that prevents you from explicitly putting admin. So with that, we still want to escape from the rest of the string. We're going to just put a semicolon since we know that works now. And now we're on to round 5. Now, in the interest of time, okay, we could have done like a union injection. That's a little bit, you get a little bit more nuance when you start getting into like the union and the intersect and things like that. But we've got a few more categories at 6:30, so I'm just going to do the exact same thing as before. Because as you can see, nothing that we're using is filtered out anymore. It is completely fine to reuse things like that if it works. What works, works. Don't break it. Don't. Oh, it doesn't work. Let's see. Okay. Where username is admin. Slash star? Yeah, let's see.
Oh, I think by union they also mean concatenation. Yeah, it works.
Okay, beautiful. Maybe because I've used the exact same one already. Maybe that, like you had asked earlier. It could be it. Like that. Right. Perfect. Now it says check out filter.php. We've already been looking at that for a while. Refreshing that actually show us how their PHP code is structured. And everything that we've seen here is pretty accurate to what we've seen before. But here's that flag. This is what you're looking for during capture the flag competitions. It's some string like this that is called a flag. And it's going to be whatever the comp's name is, typically brackets and some other information. So when you find a flag, you can take it over to that original challenge, paste it in, and then submit. I've already solved the challenge, so I'm not going to get more points, unfortunately. But we can go back to the main slides. And the next one I'm going to take a look at is command injection. Before I do that, does anybody have any questions about the SQL injection? No. It's one of the categories. It's pretty cool. It's pretty typical. You might see it a good bit. It's good. Command injection is another one. So here's an example. When command injection is possible, typically some website is executing some shell script on server side, and it's giving the user the ability to add information to what's being executed. So in this example, I'm sure a lot of you have seen like the ping domain or ping IP command. You can do it on, I think, any machine actually supports it, and that just gives you the latency of connecting to that machine. So in this example, it's a website that prompts you to enter some IP address, and it returns the information that is returned when they execute the command on server side. With that, we can do something pretty cool, which is closing that command using that semicolon like we've looked at before, even with the SQL injection, and then executing a different command. So in this example, ls. ls, if y'all are familiar with any bash scripting, is just going to show what's currently inside the directory. And so this example, we see readme.txt, index.php, user.txt. So that's one example, a very basic one, but still a good example of how command injection works. And now we can look at a workable example. I like this one a lot, actually. This one's kind of silly. So we have Calsay as a service. It actually gives us the code that's running, so we can take a look at that. That's pretty typical in these competitions and challenges. They'll probably give you some form of code that's running on the server side. That helps a good bit in figuring out what our attack vector is and how we can exploit it. So in this example, we've got a JavaScript Express server. There's a get endpoint that is the URL is at Calsay and then some message. And what it does is it executes the local application or local executable user games Calsay. It executes whatever message you put in. So, and then it'll return the result of that. So it's pretty straightforward. It's just executing a local application, passing in whatever the user put there. So we can look at this. It's telling us to make a request to the following URL to Calsay message. So we can try that. I'll just say test. And wow, we have a cal saying test. That's fantastic. So we want to try to execute some shell command. We want to get some information from the server. We already know we can inject commands because of how it was set up. So I'm going to try ls. That did nothing for us, and it actually said ls. There's a lot of different ways that we can go about this. Because right now, ls is just being passed to that file and it's being printed out. Nothing special. We're not actually injecting a command. But with a little bit of knowledge of using different bash terminals, things like that, we can do something called command, I forgot the name.
Substitution.
Thank you. Yes, command substitution. That looks like a couple of things, but I'll show the most basic form of it. And it is using a $sign and then the parentheses and whatever your command is. So now instead of putting or sending over just some simple string, we're actually taking advantage of Bash's command substitution. So when we hit enter, we see all of the local files within that directory that this application is running in. So we have a Docker file, Some of you might know Docker, that just containerizes applications. Index.js, that's the Node.js file that is running the server, similar to the one we just saw. It's actually exactly that one. But we have this falg.txt. So it's flag misspelled. And if we use a command like cat, which will read us that flag.txt file, we see our flag. So it's pretty cool. That one is a little bit more nuanced in the way that you have to understand how commands are interpreted and how bash works. But over time, you'll get a little bit comfortable with that. And you should probably get a little bit comfortable with bash anyway, because you'll see it a good bit in computer science or whatever your interests are. So anyway, we get Pico and Big Moo. I think, let me see. Yeah, I've solved this one before, so I'm not going to deal with that. But any questions on command injection? Okay, so we'll go to the next one. We have path/directory traversal. There's another really common web app exploitation techniques, and you can see a really simple example here where we're using path traversal so that we can access files or directories that are unintended for us to be seen, typically stored inside the web root. So wherever that application is running, if path or directory traversal is some valid exploit vector or attack vector, then we can typically get out of that folder and find files. So here's a basic example. This is some PHP code, just another web programming language. And the code executes get file. File is going to be passed by the user in this case. So you can go to a website and it has you upload an image or something. And then on the web's code, it's automatically redirecting you to some URL that's like including that image just by the name, which is terrible in the first place, but that's just how sometimes it is. And then it includes a file which will return that information to you. So you as the user, you're on your computer, you say, hey, I want this file, I want to view this file that I uploaded so I know the name of it, and that server is going to send that back to you. In terms of path/directory traversal, though, we can take advantage of that. Here is an example of the /etc/password file on, I think, most Linux distros. And it just shows different users, access levels, and I believe login information. So that's like a typical example. That just allows you to go to some file. That is a direct path traversal. So you're not having to use like a bunch of slashes, which if you're familiar, will bring you to the previous parent. But in this case, it is directly to etc/password. We'll go over a little bit more, I believe, simple of an example of this with forbidden paths. And this kind of shows like a very direct explanation of how this works. So it asks, can you get the flag? We know that the website files live in user/share/nginx/nginx/html, and the flag is at root/flag.txt. The website is filtering absolute file paths. So like in that previous example, we couldn't just do /flag.txt. We were able to in that previously. Now we're going to have to use relative traversal, which is going to look like a chain of slashes depending on how many directories we're traversing back from here. So we're going to go 1, 2, 3, 4, and we're going to get the root directory. We know that flag.txt is at the root directory, so it's telling us that. That is how we kind of come up with what our path traversal looks like. So I'm launching the challenge instance. A lot of these Pico challenges will have something like launch this instance. So then once it's launched, we can go to the website. So this website is an e-reader that will let you read any of those local files. So for example, we see that Divine Comedy is currently in the directory we're looking at. Reading that gives us like an entire book. Like we saw before, we can do a chain of .. slashes, which is basically telling the interpreter, go to the parent folder, 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 repeatedly, until I'm satisfied with that current location, which means I put, 4 dot dot slash chains. You're gonna go 4 folders up, and then I'm gonna say flag.txt because I'm gonna be at that directory that flag.txt is in. I know that because we just looked at the paths itself. So I'll dot slash. You can see I've done this a few times. Slash flag. Huh? Oh. There you go. So that's what that looks like. And if I've gotten the right number, yes, I can hit read and I get the flag. Something interesting though that you might not consider is, since we know flag.txt is in the root directory, which is the highest level most directory, it's the parent to all of the directories that we can see. We can just do a ton of dot dot slashes because you can't get higher up than that. So when we know that flag is at the root, this could look like 8 of these. Now there's not 8 parent folders to traverse, but it doesn't matter because the rest are just going to be negated. It doesn't matter. So you can do that. You get the same result. So that's one example of path traversal. We could be in the URL. The URL could be an absolute path, and we could just add dot dot slash to it, and it'll go to the previous location. So there's just a lot of different ways this can be applied, but the basic principles of it still apply, that you're just traversing different directories, different paths to get to different files that you're not originally supposed to be able to get to. So these last two, I don't have work examples of them, but I think I've hammered a lot of information into your brains. So let's go over some basic. So we have cross-site scripting. This one is very, very common in the more complicated challenges. Now, don't get me wrong, there are simple challenges with it, but we get a lot more nuance when we get to this. So it's when an attacker uses some type of web app exploitation or web app to send malicious code, which is typically browser-side script, to another end user. So this could be present in different things. In this example, we have like a post comments. So like on forums, there can be a ton of comments, and if the user adds certain JavaScript code to that comment that may be executed at some point, then that is an example of cross-site scripting. So say that I was to comment script alert cross-site scripting attack. That will be a comment that is if it's not sanitized properly, which is a little bit difficult to get like that to properly work because it typically should be. It won't be in the context of these challenges though, sanitized. So if I put this comment, then later when another user goes to the website and this code is executed, that adds all of the comments to your DOM, which is the document. You're gonna have an alert, which I'm not sure if y'all are familiar with that, but it's just like you're on a window and there's like a pop-up at the top that says some information. Or there's like, in terms of UGA students or college students, we typically see like a login form right there. But this one, in the most basic form, is gonna give us XSS attack. So that's one example of how cross-site scripting works. You are putting some malicious code that is going to be executed on somebody else's computer. Not good. The last thing we have is cross-site request forgery. So it's a little bit similar to how cross-site scripting works, except here, instead of just executing some simple code that exists there on that machine, now it's going to be doing some type of data transfer, some type of exfiltration of data through different requests. So what this might look like in this case is this website has vulnerablewebsite.com, very on the head, has a email.change endpoint. So as a user, and this is super unrealistic, but I don't care. As a user, you're gonna have some type of page that you put in some email that changes your email for that website. Well, say that somebody was able to execute this request without you knowing, was able to make your email get changed to something they have control over, you would be out of your account and they would be in it. So what this might look like is taking advantage of certain poor rendering of like an image, where the source is this request. and it changes your email to pwned@eviluser.net, something like that. Now that user has complete access to your account, and you didn't even know it, simply because that website was poorly set up to enable cross-site scripting or cross-site request forgery to work. Nowadays, there's tons of different security techniques for that, but it's still something that exists today, and it's something to be aware of. And for us, it's something that allows us to succeed in challenges, if you know it. Any questions on that? So here's our attendance, Discord, and our link tree for various hackpack links. I know it was a lot of information today, but web app exploitation is one of those really fun categories because it's right in your face. You use websites every single day, and this happens every single day. So it's something really cool to be aware of and to get into. And I'm always here to help you out anytime.